In this video, we're going to use Matlab to solve a simple geometry problem. So let's read the problem statement here. It says, use Matlab to calculate all unknown angles and side lengths in the triangle below. Then calculate the perimeter and area of the triangle. Then repeat the calculation after changing the angle to 65 degrees. Leave the given side lengths unchanged. Okay, so let's see how we're going to do this. So first, we have to remember, how do we calculate these angles and these side lengths? Well, let's start by calling this A, defining some variables here. B, let's call this angle alpha, and then let's call this C. We'll call this angle beta, and we'll call this angle phi. Now, looking at that, so we need what we need to find, we need to find beta, phi, and c. So digging back in our memories, let's remember how we can do that. Well, first of all, to find c, we can use the cosine law. To find c, and that is c squared is equal to a squared plus b squared minus 2 times a times b times the cosine of alpha. Okay, so there's the cosine law. And then for beta and phi, we can use the sine law. The sine law tells us that b over the sine of the angle opposite beta is equal to c over the sine of alpha, which is also equal to a over the sine of phi. So we've got those two pieces of information. We also need to calculate then, now we know how to find all of the angles and the areas and the side lengths, but now we need to find the area and the perimeter. Well, for the perimeter, that's easy. Let's call that S, and that's just going to be A plus B plus C. For the area, that's going to be big A is 1/2 times base times height. Well, we can define the base and the height. If we drop perpendicular like that, then our base would be B, the same B, and our height would be A times the cosine, A times the sine of alpha. So we've got pretty much everything we need here, and now let's move over to Matlab and solve this problem. Okay, now we're over in Matlab, and I've set this up so that the video is just recording the command window, and you can also see the workspace and the command history. So the first thing I'm going to do is write a comment. We can use the % sign to write a comment. This is just information for us, and this is going to be our example problem. So that's really helpful to do when we start programming, and I'm doing it here also to help make this video, make some comments here in the video for your notes. First thing we're going to do is define the variables we were given in the problem. So we know A equals 2 and B equals 5. We're just using those. And then alpha equals 75. And I'm going to put a note here that that's in degrees so that we remember that. And we'll hit enter, and you'll see over here in the workspace, those three variables are now created in the workspace, and as we've been working, the command history is recording what we're doing. So the first thing we did was use cosine law to solve for c. So I'm just going to input that here and see what happens. So we know that c squared equals a squared plus b squared minus 2. Now you need the multiplication here. A times b times cosine, I'm going to use cos d for cosine in degrees of alpha. Okay, so let's try that. And you see we have an error, and this is what I was talking about in the video. The expression to the left of the equal sign is not a valid target for an assignment. And what we're learning here is Matlab does not do algebra for you. So you actually need to do the algebra to solve for c, which in this case is just taking the square root of both sides. So we can rewrite that. I'll hit the up arrow to bring up the same equation, just to scroll back through the command, and say c is equal to square root of all of this stuff. And now we've calculated c, 4.8809. So the next thing we need to do is to calculate those angles. And again, doing the algebra from the sine law, we see that beta is equal to a sine, I'm going to do a sine d. Well, hold on, let's make sure we have an a sine d. So one way to find that is to just type a sine d and see if anything comes up. Or let's type help a sine d. Now if this is a built-in function in Matlab, we'll get some information. And we do. A sine d is the inverse sine with the result in degrees. So that's what we hoped it would be. So now we will type beta equals a sine d, inverse sine in degrees, of b divided by c times the sine d of alpha. And you can go back and check and you'll see that this is the correct algebra to do this calculation. Okay, so that gives us beta. So beta is 81 degrees. Next, we can calculate the other angle, which was phi. And what I'm going to do is again just scroll up and do some changes here. So phi is equal to a sine d of a divided by c times the sine d of alpha. And phi is 23.3 degrees. So we've got all our angles and side lengths now, and the next thing we need to do is calculate the perimeter. So the perimeter, I'll use a descriptive variable now, we'll call it perim, and that's equal to a plus b plus c. The perimeter of this triangle is 11.88, and then remember that the height, the area is going to be 1/2 times base times height, and we determined that the height, h, is equal to a times the sine, I'm going to use sine d of alpha. So there's h, 1.93, and the area is equal to 1/2 times b, and that was the same b, times h. And now we've got the area. So here's all our answers here. They're all in our workspace, and we're not going to talk about about kind of presenting those answers in a more usable form, but they're just in our workspace. We've calculated them. We could then go use them to do more calculations. Later on, we'll talk more about presenting those answers. Right now, we're just doing the calculations, and we've got the results. And then the last part of the problem was to do all this again, but change the angle to 65 degrees. So what I want to show here is how quickly we can do that. Now that I've got these answers, what I'm going to do is create an alpha 2 and call that 65 degrees. So that's going to be 65. And then we can just use our command history now to go through and do all the same calculations, but now using alpha 2. So the first thing we did is we used cosine law. So I bring the cosine law. All I'm going to do is change this to alpha 2. And I'm going to go ahead and change this to the target variable for the assignment just to C2, because this is the second part of the problem and I don't want to overwrite the old information on C. So now we calculate C2. Then the next thing was to calculate those angles, so beta. Oops, let's get rid of this bit here. We'll call this beta 2 is B over C2 sine D of alpha 2. And then, so now it's 88.6. We're almost at a right triangle now. And then next was to calculate phi, so I will click and drag that over from the command window. Again, just changing this to alpha 2, changing this to C2, changing this to phi 2, and we'll hit enter. Now we have our angles and side lengths. The next thing we had to do, and we can look back in the command history and see it, there's the perimeter. The only thing we have to change here, A and B are unchanged, so we just change that to C2. And next we calculated H. So let's do that calculation. We'll drag that in here and we'll call this H2. And lastly, we'll calculate the area. And that's going to be, call that area 2. And now we've done all our calculations. And what I'm going to do now is I'm going to bring the workspace, I'm going to undock the workspace here, just so we can see it a little bit larger. Bring it into our window, and scroll it down, resize it. So now we can see all our variables. So there's A, B, and C, C2, H, and H2. So we can see how things are changing when we change the alpha equals 65. So that concludes this example. We're going to go back and just talk a little bit about our problem solving process here. Okay, so let's review what we did to solve that problem. The first thing we did, like any problem in math or science, is we read the problem carefully and we identified what we were given and what we needed to find. Then, now, since this isn't a specific class, we had to really remember or maybe go out and research any relevant principles, theories, and equations to apply to that problem. So in this case, we started with cosine law and sine law. And we had the equation for the perimeter of a triangle and equation for the area. The next thing, and we had to do, and it wasn't too hard in this case, is we had to perform any necessary algebra by hand and determine the order in which we did the calculations. We had to make sure to do them in the right order. And then we started inputting the problem solution into Matlab. And the last thing you always want to do is review your results using your technical judgment, which is growing as part of your education, hopefully, and just common sense. For example, don't calculate the mass of a car and determine that it's 100 grams. That probably wouldn't make much sense unless it's a little toy. And that concludes this first example.